All right, let's go with our next lecture here. Today we're going to be looking at balancing chemical reactions. The reason we need to balance these chemical reactions is because of the law of conservation of matter, which states that in either a physical change or a chemical change, no new matter is destroyed or created. It just changes how it's either, in a chemical reaction, it's changed to form new compounds. In a physical reaction, you're just changing the state of matter usually. So if we look at this equation here, we're saying that we have one iron atom here and a diatomic oxygen molecule, and they're reacting to form this iron 3 oxide here. But what we see is, on this side we have one iron atom, and all of a sudden there's 2 iron atoms over here, and that would violate the law of conservation of matter, because we're not just going to make this extra iron atom appear out of air. And so what we have to do when we balance the equation is make sure we have the same number and type of atoms on both sides of our arrow. So the way I would recommend doing this is starting with just putting what atoms you're trying to balance here, and then kind of draw a line. And this is kind of our equivalence point, so we need the same number on both sides. So if we look over here, we have one iron atom, and we have 2 oxygen. This is telling us 2 of everything before it, so 2 oxygen. On this side of the arrow, we have F with a subscript of 2, so that tells us there are 2 iron here, and oxygen with a subscript of 3, so there are 3 oxygen atoms. So we're unbalanced. On this side of our arrow, we have 1 iron atom, 2 oxygen atoms. On this side, we have 2 iron atoms and 3 oxygen atoms. So we have to do something to make this balance so there's an equal number on both sides. And what we can do is we can change the coefficients in front of these molecules here, or these atoms. So we could put a 2 here, and that would say we have 2 iron atoms. All we're doing is changing the coefficients till we have the same number on both sides. The difficulty with balancing equations is there are no real set rules on how to proceed. And what I would recommend is that you leave anything that's elemental to the end, and you start with your more complex compounds first. In addition, what I would do is I would look to see if I have an odd number of something on one side and an even number on the other side, because there's no number that we can multiply an even number by to make it an odd number. So for example, here we have an even number of oxygen and an odd number, so this number is going to have to become an even number. So to proceed, I would put a 2 in front here, and that's multiplying everything behind it by 2 with that coefficient. So now I have 4 iron atoms and I have 6 oxygen atoms. That didn't bring us any closer to being balanced, but now we have an even number of atoms on this side, and so we can balance the rest of our equation because we don't have this odd even imbalance. Right, so on this side I have 4 iron. Here I only have 1 iron. So I could put a 4 coefficient in front of this iron, and now my iron is balanced. And then I could put a 2 or a 3 in front of this oxygen, and then I have 6. And so my iron and oxygen are balanced on both sides of my equation. Now I have 4 iron atoms, and 3 times 2, 6 oxygen atoms. 2 times 2 for 4 iron, 2 times 3 for 6 oxygen. Right, so remember, this is telling me I have 3 diatomic oxygen molecules. Each of those molecules contains 2 oxygens, so there's 6 total oxygen atoms. So let's look at another equation and try to balance that equation. And really the only thing you can do is practice balancing these, and hopefully with some experience you'll get better at them. So if we take a water molecule and we break it down into hydrogen and oxygen, again, we look at this and we can see this is not a balanced equation, right? Because we start by putting the elements we have here in the middle. And on this side I have H2O, so I have 2 hydrogen and 1 oxygen. And on this side I have 2 hydrogen and 2 oxygen, so I'm not balanced. And what someone might be tempted to do is to say, well, look, I can erase that. Now I'm balanced, right? But in balancing equations, we can never change the subscript because that changes the actual compounds we have, or diatomic molecules we have. So what I would do if I'm balancing this is, again, I would look and say, well, I'm going to save these guys to the end because they're just one element. So putting a subscript or a coefficient in front of here only changes the number of one thing. If I put a coefficient in front of this water molecule, it's going to change the quantity of two things, right? And so I also see I have an odd number of oxygen here and an even here, so I'm at least going to have to multiply this by a 2. Right, so when I do that, it unbalances my hydrogen, but then it balances my oxygen. So I have 2 times 2, 4 hydrogen and 2 oxygen. On this side, I have 2 oxygen, so my oxygen are balanced, but my hydrogen are not balanced. So I need to put a 2 here, and then I would have 4 hydrogen and 2 oxygen. So I have a balanced equation at this point, where I have 4 hydrogen, 2 times 2, 4 hydrogen on this side, 2 times oxygen, 2 oxygen on this side, 2 times 2, 4 hydrogen, and then 2 oxygen on that side. So I have my equation balanced at this point. And we'll do another one here. So if we have a N2 nitrogen gas and we're adding it to oxygen gas, we're producing N2O5. We have an unbalanced equation here, right? We have, and we can visually see that, but we'll write it out down here. So on this side of my arrow, in my products, I have 2 nitrogen and 5 oxygen atoms. On this side, I have 2 nitrogen and 2 oxygen. Right, so I have an uneven number here. I have an odd here and an even here. These are both elements by themselves, so I'm going to save those to the end and start with the most complex molecule first. So I have 5 here. I need to make that an even number, so I would start by putting a 2 here, right? So by putting a 2 there, I'm multiplying. I say I have 2 dinitrogen pentoxide molecules, so I have 4 nitrogen now and 10 oxygen. I'm pretty sure we're going to balance at that point, so I will prematurely circle that. Now we're going to come over here and say, well, now I only have 2 nitrogen, but I have 4 over here. So I could put a 2 in front of this, saying I have 2 of these. So that would give me a 4 here. I have 5 oxygen on the right of the arrow and only 2 to the left. So if I put a 5 there, that would give me 10 here. So that's the basic procedure for balancing a chemical equation. We kind of take stock of what we have, and then we start adding coefficients and going back and forth until everything is balanced on both sides of our arrow.